Hello everyone, welcome to RN tutorials on engineering mechanics. So in this video lecture I would like to explain how to find out a force which can make the body under equilibrium whenever it is subject to some force which is acting at a particular angle to the inclined plane. So that means here again the same heading, equilibrium of a body lying on a rough inclined plane when subjected to force at some angle to the inclined plane. Here the plane means which is the inclined plane. So which is similar to the previous cases we have already discussed, but here the force condition is which is acting at a particular angle to the inclined plane here. So let us consider a body here. We need to again assume a body on a rough inclined plane as shown in figure. So assume this is a plane, inclined plane, rough plane, and on which we are going to place a body. So here first again I have represent the inclination of the inclined plane with the horizontal base, and next we have to consider a body which is of weight W, and to this W whenever we place certain normal reaction acts, we already know, so we need to represent with R. And next the force which is required to make the body in equilibrium condition. So here assume the body is moving downward, so whenever it is moving downwards the plane, here we need to apply certain force. Okay, assume P we are applying here. The condition is this P should be inclined at a particular angle to the inclined plane itself, not to the horizontal here. So this force, whatever the P we are applying, that is inclined to the inclined plane. So it is inclined to the parallel line to the inclined plane, means automatically this line will be inclined to the inclined plane only. So assume which is the P which is acting at an angle of theta here. So first case we need to find out what is the minimum force which can make the body just to stop. That means which can make the body under equilibrium, and that is the minimum force which can just to stop the body other than moving downwards. Okay, so whenever we uh, uh, make the force less than the P, automatically the movement starts to the downward direction. So that means still it is trying to move in downward direction, but we are just stopping. Means again we have to analyze that the force, frictional force, will be acting again upwards the inclined plane when the force is minimum, and which can make the body to stop, means which can make the body to be under in equilibrium condition. Okay, so these are the forces we can consider: frictional force, normal reaction W, and the force which is required to make the body in equilibrium, that is P, and it is acting at an angle of theta. And next we need to resolve the forces along the plane and perpendicular to the plane. So here the P can be resolved into two components according to the theta, that is an angle made by P with the inclined plane. So how can we, means, so here for understanding purpose I have extended this R. So next the same I said, we need to resolve the P into two components. So like this horizontal and vertical component, means which one is parallel to the inclined plane and another one is perpendicular to the inclined plane. So that I want to represent separately. So whatever components we have divided, same components I have represented here for our convenience when you are going for calculation. So this component which is parallel to the inclined plane becomes P cos theta, and this component which is perpendicular to the inclined plane becomes P sin theta. Okay, these are the two components you can resolve for the P, that is along the plane and perpendicular to the plane. And next we go for resolving the W. Okay, W is exactly vertically acting downwards. So this W can be resolved again into two directions: one is perpendicular to the plane and another one is parallel to the plane. Okay, so again as shown in figure, like this we can resolve. And again I want to represent this W separately for our convenience. So here the angle is alpha. So why it is angle, means from the theorem of perpendicular, the angle between W and R becomes alpha only. Perpendicular means W is perpendicular to the base, and this R is perpendicular to the plane. So these two, the angle between these two lines, inclined plane and the horizontal base, is alpha. Similarly, the lines perpendicular to these two lines again makes same angle. Okay, that is from the theorem of perpendicular angles. Just try to analyze that. So now again I want to represent it separately like this, perpendicular to the plane and along the plane. So perpendicular to the plane becomes w cos theta, and along the plane becomes w sin theta. Okay, so these are the forces we can resolve for w and p force. So let us go now for considering the parallel forces and perpendicular forces for considering the equilibrium of body. So next, first we go for from the forces parallel to the plane. So again, the forces parallel to the plane, we need to consider all the forces parallel to the plane. Next, so what are the forces are parallel to the plane? One is p cos theta parallel to the plane, that is the p component which is parallel to the plane. Again here this is p cos theta, and the frictional force is already acting parallel to the plane, and another one is w sin theta. According to the direction we need to take the sign, or otherwise we can make them equal. So for frictional force F and parallel component of the P are acting in same direction, so we can write it as P cos theta plus F is equal to, we can write it as the W sin theta is opposite, acting opposite to these two forces, so automatically equal to, we can write it as W sin alpha. So why? Because means we are making the body under equilibrium condition, so opposite forces we can make them equal. And try to write F is equal to W sin alpha minus P cos theta, and remember this equation or make it as a one equation. And similarly we go for forces perpendicular to the plane. So again we need to consider the forces perpendicular to the plane, and we need to apply the equilibrium condition. So what are the forces acting perpendicular to the plane? One is normal reaction, and another one is component of a W that is perpendicular to the plane. Okay, and again the component of the P that is also perpendicular to the plane. Here P and R both are in same direction and perpendicular to the plane, so we can take the sum of these two. So we can write it as R plus P sin theta is equal to, we need to write W cos alpha. Why? Because W cos alpha is acting opposite to the R and P. So sum of R and P sin theta is equal to W cos alpha. So in this equation again try to write R is equal to W cos alpha minus P sin theta. So assume this equation as 2, or remember this equation, and again I would like to produce these two equations in the next slide for our easy calculation. So these are the two forces we got by considering parallel and perpendicular forces to the inclined plane. So next we go for the formula for the friction. Already we know that the frictional force is equal to mu r. So try to substitute that F and R in this equation. As usually we know W sin alpha minus P cos theta is equal to mu into W cos alpha minus P sin theta. So now take the mu value inside. Okay, mu W cos alpha minus mu P sin theta, and now make the P terms to one side and W terms one side. So mu P sin theta minus P cos theta. Here this mu P minus mu P sin theta, which is on right side, we have taken to the left side, so automatically it becomes positive. And here already minus P cos theta is there, as it is we need to write minus P cos theta. And next we need to write mu W cos alpha remaining element, and when we take this W sin alpha to the right side, then it becomes minus W sin alpha. Okay, so now go to the next slide with the same step. Now I want to take the P as common. P of mu sin theta minus P cos theta is equal to, I want to take again W as common, W of mu cos alpha minus minus sin alpha. So now you try to write P is equal to, we can write it as W of mu cos alpha minus sin alpha divided by mu sin theta minus cos theta. Okay, now again we know that mu coefficient of friction is equal to tan phi. That tan phi can be written as sin phi by cos phi. So in the above equation, in place of mu, again we need to write sin phi by cos phi. So we go to the next slide. So in this equation, in place of mu, we need to write sin phi by cos phi. So W of sin phi by cos phi into cos alpha minus sin alpha, and divided by, again mu means sin phi by cos phi into sin theta minus cos theta, and take the LCM. When you take the LCM, the LCM is cos phi, so in the denominator cos phi and cos phi will be getting cancelled above and below. Okay, now when you take the LCM, we can write it as W of already sin phi cos alpha we can write, sin phi cos alpha. So when you are taking LCM, we need to multiply this cos phi to the sin alpha minus sin alpha into cos phi, and again divided by, we can write sin phi into sin theta, okay, and minus cos theta into cos phi. We need to multiply this cos phi to this cos theta, then minus cos theta cos phi. Okay, this is the equation we got. P is equal to, again produce, I want to produce the same step, so this is the same step previously we got. So now if you carefully observe, it can be in the form of sin a cos b minus cos a sin b. Similarly here it will be in a form of cos a cos b minus sin a sin b. Here the cos terms are here and sin terms are here. So for our easy convenience, take the negative as common in the numerator and denominator, then the negatives will be getting cancelled and the elements will be reversed. So I want to write that reversed form, sin alpha cos phi. This sin alpha cos phi got, that is sin a cos b minus cos a sin b will be getting when you take the negative as common, and divided by, again cos terms and sin terms are replaced here, and it becomes cos comes to the left and sin terms comes to the right when we take the negative as common. So now cos theta cos phi, that is cos a cos b minus sin a sin b. Now directly we can write it as P is equal to W of sin alpha minus phi means sin a minus b, and similarly cos a plus b means cos theta plus phi. Okay, this is the final equation, which is the minimum force required to just to stop the body to avoid the movement on the rough inclined plane, which can make the body under equilibrium condition. When we are applying the force inclined at some angle to the inclined plane itself. Okay, so same procedure, except we need to indicate the force, that is the P, which should be acting at a particular angle theta. Then we have to resolve it, then we need to consider horizontal and perpendicular, then we need to apply the equilibrium condition. So same steps related to the previous videos we have already discussed. Then we'll be getting the equation like this: minimum force P is equal to W of sin alpha minus phi by cos theta plus phi. And similarly when we go for a maximum force, so maximum force at which the body will be under equilibrium condition, more than that force, again the body starts moving in upward direction. So in this condition, again the frictional force acts downwards the plane. So the same condition we need to resolve the components of for P and W. Then we need to analyze the parallel forces and perpendicular forces, and we need to apply the equilibrium condition. Then again we need to go for friction equation and coefficient of friction equation. By all that modification, again we'll be getting one equation. So that equation is in the form of P2 is equal to W of sin alpha plus phi by cos theta minus phi, opposite to the first equation. This is sin alpha plus phi by cos theta minus phi. So this is the equation we'll be getting when we solve by considering the maximum force which can still make the body under equilibrium condition. More than that force, again remember the motion of the body starts in upward direction. So okay, so again here the frictional force will be acting opposite to the motion in which it is tends to move. Okay, so this is the procedure that we can easily understand, because already we have discussed 2 times and 3 times according to the case 1 and case 2. So I hope you understand how to find out again the minimum force which is acting at an angle theta to the inclined plane, and that is required to make the body under equilibrium, and as well as the maximum force. And still, if you have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. And please share my videos, like my videos, and if you have not yet subscribed, please subscribe to my channel and encourage me to upload more and more videos. And once again, thanks for watching. Thank you all.